analysis will focus on cloud versus on-premises. The rapid growth of cloud DBMS offerings is providing organizations with cost-effective alternatives to on-premises systems. Many shops are now considering cloud databases as attractive alternatives to the more traditional on-premises data stores. Numerous industry pundits and database vendors are guaranteeing that cloud systems are the solution to all of our database challenges. The seemingly endless array of offerings can easily become bewildering. Even Gartner is stating that the cloud is in danger of becoming overhyped, and they've coined a new term. They call it cloud washing, which means even if your offering doesn't effectively support the cloud, you're telling everybody that it does. As we move through the slides, I won't be rattling off all the bullet points. As I said, we'll be sending you a SlideShare link, which will allow you to download the presentation. But we will cover some of the stronger pros and cons. The top benefits I see are not having to spend the money on infrastructure components. Let me give you an easy example. DR. Most cloud providers offer geographic data redundancy as an integrated part of their service offering. That's a pretty costly architecture to build on your own. Highly available architectures, also complex and costly. They are cheaper and easier to build in the cloud. You're not required to lash the various pieces of hardware together. The cloud provider does that for you. There's no need to worry about over or under provisioning your environment. You rent your environment and then leverage the provider's elastic scalabilities to scale up or down. It's based on the horsepower you need at that time. You can also let the provider spend their money on R&D and leverage their efforts. The weaknesses will include having to train your personnel to support an entirely new architecture. We dedicated last month's presentation to this topic. It was titled Cloud DBMS Architectures, Its Impact on IT Organizations, and that impact is greater than you think. You can find a copy of the presentation on SlideShare. Just do a search of Cloud DBMS Impact. Because of the changes you'll be required to make to tailor your application in DB to the provider's architecture, there's a good chance that you're going to get locked in. Each shop has their own views on vendor lock-in. Some shops are more comfortable with it than others. In addition, not all database-driven applications are cloud-friendly. Databases that have a lot of interaction with other systems, they depend upon large input files or generate large output files, or they're governed by internal, industry, or governmental regulatory requirements, may not be best suited for the cloud. In addition, visibility into the system can be challenging on cloud architectures. Most shops, when we talk about on-premises pros and cons, most shops have a major investment in their infrastructure. What happens to that hardware when you move to the cloud? Certainly you can decommission as you migrate, and there are vendors that will buy your used equipment. Gartner states that security is the #1 concern when organizations are considering cloud migrations. Whether or not that lack of security is entirely true, many shops just don't feel comfortable sending their data to a shared cloud offering. #2 is loss of control over their environment, the trust factor. #3, vendor lock-in. And #4, a lack of visibility into their cloud environment. As administrators, visibility into our systems is important. Auditing, security, administration, monitoring. Third-party app and tool vendors understand that they need to support cloud architectures. Many of them have made their products cloud compliant, but not all of them are there yet. In addition, I've used both cloud and on-premises monitoring administration tools. The on-premises tool sets have greater functionality than their cloud counterparts. There's no doubt that the cloud vendors will make their products more robust and more feature-filled, but right now, on-premises offerings have better tool sets. The weakness of on-premises are the cost to build and administer the architectures. You have to buy it, build it, and then support it. Seems like renting it and having others share administrative duties with your shop is an attractive alternative. Cloud systems also allow you to be more nimble, agile, and scalable. You can more quickly take advantage of the latest technologies and features. The cloud's a very competitive environment. It's forcing all the vendors to release new features and functionality they have to be competitive. What environment's better? Cloud, on-premises? Actually, right now, neither. It's going to be hybrid environments. We know that cloud and on-premises systems will coexist for the foreseeable future. Now the challenge becomes, how easily can we administer both of those DBMS environments? The majority of database vendors' on-premises database offerings differ from their public cloud counterparts. In addition, public cloud implementations of the same database product may differ from each other. For example, Oracle, Amazon, MariaDB, and Google all offer cloud versions of MySQL. And although very much alike in many areas, they also have key differences. The environments offer different database features and functionality, data access mechanisms, administrative processes and interfaces, maintenance utilities, the list goes on, monitoring, security controls, backup recovery, disaster recovery, tuning, and performance. For this discussion, hybrid clouds are the DBMS vendors' attempts to overcome the lack of consistency between public cloud and on-premises DBMS systems. A utopian hybrid cloud will be an environment that has a combination of public and private cloud DBMS architectures that are totally transparent and seamless to both administrators and developers. For developers, it'll be an environment that allows 100% code compatibility between private and public clouds. For DBAs, it will be an environment that is monitored and administered exactly the same way, regardless of whether that system is running on a server in the shop's data center or in the public cloud. Hybrid clouds will provide organizations the option of easily deploying database systems to the architecture that best fits their application's unique processing requirements. Let's dig into this a little bit deeper on the next slide. Our two heavyweight contenders on the database market arena, Oracle and Microsoft, they both understand how important it is for customers, especially those that have a lot of on-premises systems, to be able to make a seamless transition to cloud architectures. Both of those vendors' strategies are hybrid clouds. Their strategy is to allow administrators to use the same tools on both systems and to provide an exact feature match between cloud and on-premises environments. Oracle describes it as the single pane of glass. As the number of applications migrating to the cloud continues to increase, hybrid clouds will become less important, but that's going to take years. It's obvious that the cloud consists of more than just Oracle and Microsoft. We are beginning to see the monitoring tool vendors transform their products to allow customers to seamlessly monitor cloud and on-premises databases. In addition, the larger administrative tool vendors are also moving in that direction. Amazon is also getting the hint, stating that one of their core strategies is to provide customers with a more seamless hybrid architecture that allows its offerings to more easily interact with on-premises systems. It will also offer tool sets that allow a more transparent view of both cloud and on-premises architectures. Let's continue our focus on cloud architectures by looking at the three heavyweight contenders. For those organizations that are contemplating public cloud DBMS implementations, there's dozens of architectures and vendor offerings available. We'll talk about a couple of those in upcoming slides. The alternatives range the spectrum: pricing, features, administrative control. Customers can choose from IaaS environments, infrastructure as a service, which provides them with total ownership of their software stack's administration, most often from the OS up, all the way to DBPaaS systems, database platform as a service, which significantly raises provider control over the customer's environment. Performing a feature-by-feature comparison of the vendors is far beyond the scope of this presentation. There's a myriad of individual evaluation criteria that needs to be identified, weighted, ranked, compared, and analyzed. I've written a white paper that provides a high-level overview of cloud DBMS evaluation best practices. Because of the importance of choosing the most appropriate cloud architecture and cloud DBMS provider, RDX also provides Cloud DBMS Advisory Service, which helps our customers with cloud vendor analysis and selection. Let's talk about Amazon. Amazon currently offers a broad and deep suite of cloud DBMS services. Customers can choose from fully managed products that include Relational, Aurora, its DynamoDB product, NoSQL, Data Warehouse, Redshift, and in-memory Elasticache. Amazon's RDS product suite provides consumers with 6 managed database engines that include Microsoft SQL Server, Oracle, MariaDB, MySQL, and PostgreSQL. On the other end of the management ownership spectrum, Amazon's EC2 provides customers with a greater administrative control over their entire software stack, which includes their database instances. This wide array of offerings allows organizations to choose their cloud DBMS architecture of choice, from single-tenant traditional IaaS models that provide them with a high level of administrative control to multi-tenant DBPaaS environments that turn over ownership of many of the day-to-day administrative duties to Amazon. When compared to Oracle and Microsoft, Amazon's fully managed products their product offerings are traditionally viewed to be less competitive in a head-to-head comparison of database features and functionality. But in order to perform a thorough comparison of the vendors, we can't constrain ourselves to just analyzing database features alone. We must also examine the vendor's entire suite of offerings, as well as their cloud DBMS ecosystem. An ecosystem that includes the range of architectures available, their pricing models, provisioning, geographic data redundancy, compute and storage architectures, security controls, administrative tools, edge technologies, and products. Amazon, by the very nature of its business offerings, is the most mature provider of cloud architectures. As a result, it has a significant head start on its 2 main rivals. Microsoft comes in a very close second. Remember that we are comparing the suite of cloud offerings, not individual database products. Amazon provides the greatest number of cloud DBMS alternatives. But when you compare their cloud provisioning, security, administration, compute, and storage architectures, Microsoft Azure is rapidly closing that functionality gap with Amazon. Some may argue that the functionality gap is already closed between those 2 vendors. Azure is and will continue to be the platform of choice for customers who are strongly committed to the Microsoft technology stack. Microsoft's strengths are its hybrid architecture, huge customer base, and SQL Server's robust feature set. Let's differentiate between SQL Server Azure, which is Microsoft's database platform as a service, and Azure itself, which is a general cloud service offering. Although Microsoft does allow customers to run their databases of choice on Azure, support is spotty and it can get kind of kludgy. The level of frustration depends on the DBMS product you're trying to run in Azure. You can't compare Azure's IaaS architectures for non-Microsoft database products to Amazon's. Amazon just provides a much more robust environment for a wider range of database products. Oracle entered into the cloud war later than both Amazon and Microsoft and has some catching up to do. The DB vendor has launched an all-out offensive to challenge both Amazon and Microsoft. They hired Peter Magnuson from Google as their VP of Cloud Development, and they stole Don Johnson from Amazon as their VP of Engineering. Larry Ellison pretty much declared an all-out war against Amazon in his 2016 Oracle Open World keynote. Allison has already taken a hardball approach against Amazon. Oracle recently announced that they've updated their cloud licensing policy. They use something called an Oracle Processor Core Factor Table, and that Oracle Processor Core Factor Table is no longer applicable to authorized cloud environments. Here's what that means. The Intel core factor in that table is 0.5. So an 8-core physical box requires 4 cores of licensing. Now on the cloud, an 8-core now requires 8 cores of licensing. The end result is that it's doubling the required number of processor licenses to run the Oracle database on Amazon. So as usual, Oracle pulled the nuclear trigger. Customers that want to run Oracle in the cloud will have to choose Oracle's cloud offering, or they're going to pay higher licensing costs if they want to run the same product in AWS. Oracle is still defining its cloud strategies and architectures. As I stated earlier, it has some catching up to do. The challenge for Amazon is that it has a limited ability to provide on-premises or hybrid DBMS cloud services to its customers. It will be relegated to a cloud-only DBMS services provider. Until consumers begin to more widely adopt cloud DBMS systems as their architecture of choice, it will not be able to challenge Oracle's or Microsoft's market leadership position in overall DBMS revenue. But neither Oracle or Microsoft can match Amazon in breadth and depth of product offerings. Amazon offers MySQL, PostgreSQL, Aurora, SQL Server, Oracle, DynamoDB, and the list goes on and on. In addition, since it's had a head start on its competitors, it has built a very robust cloud service architecture. And Amazon has the funds and expertise to constantly expand into new offerings and improve upon the existing ones. Amazon customers will have the continued ability to choose from a wide array of database products and custom tailor a cloud architecture that meets their needs. Oracle and Microsoft's hybrid environments will become the architecture of choice for customers who are committed to Oracle's and Microsoft's product offerings. They will also become attractive alternatives for those shops that prefer the freedom to choose between cloud and on-premises database implementations. Let's move on to our next competitive analysis, which focuses on the increasing amount of competition in the DBMS market arena. The market landscape no longer consists of a handful of traditional on-premises relational database offerings. The market's exploded with dozens of new database architectures and products that range the spectrum in price points, architectures, storage models, and feature sets. Gartner's 2016 Magic Quadrant for Operational Database Management Systems includes 21 different vendors. We have supersized competitors like Amazon and Google with huge R&D budgets and engineering resources. They now offer database products to the IT consumer. Amazon's DynamoDB and Google's NoSQL Cloud Big Table offerings are enticing customers looking to store and process large volumes of unstructured data. On the other end of the spectrum, we have startups that are identifying functionality gaps, and they're quickly creating products or services that fill them. Most shops shied away from open source products that weren't commercially supported. They felt uncomfortable implementing critical or mission-critical applications that were publicly supported. I call it crowd support. A new class of service providers like EDB, DataStax, MongoDB, Percona, and MariaDB now offer 24/7 support for PostgreSQL, Cassandra, MongoDB, and MySQL. When we look at Oracle SQL Server, both products have a robust set of features, and it's our responsibility to provide the greatest database functionality at the lowest cost to our customers. The bottom line is, the more options and features the database provides, the easier it becomes to implement apps and the more flexibility it provides to DBAs and developers. The more solutions the database inherently provides, the more cost-effective it becomes. These integrated features allow you to solve business problems without the additional costs of writing custom code or integrating multiple vendor solutions. The industry heavyweight offerings are mature, and the vendors have large support organizations. In addition, you don't have to worry about your DBMS product manufacturer getting purchased, merging, or going out of business. That sense of stability is comforting. Because of the heavyweight vendors' large customer bases, most third-party application vendors make sure that their applications work with their products. Weaknesses include the costs. You can get locked into their platform, and somewhat predatory licensing practices. You can search the web and you'll find the two top vendors for licensing audits are, guess who? Microsoft and Oracle. Oracle's getting some very bad press lately. Late last year, Fortune magazine ran an article stating that Oracle is using audits to force customers into its cloud offering. The customers are offered a deal to reduce their true-up costs if they agree to purchase cloud credits. Forbes interviewed a lot of Oracle customers. All the respondents stated they felt Oracle makes it difficult for companies to know if they are in compliance or not. If we look at these increasing number of competitors, the strengths, their solutions are unique, and they do leverage some of the latest leading-edge technologies. Amazon allows you to fully leverage the cloud. You can build your entire app on their systems for a cost that is far less than building it on premises. NoSQL vendors, they provide customers with the ability to custom tailor a storage architecture that meets the application's unique needs. Many of the NoSQL offerings allow customers to leverage low-cost hardware to enable absurdly high degrees of horizontal scalability. Instead of adding CPU, memory, and disk into a single chassis, you can add additional chassis into the cluster. Now you can scale vertically within a chassis, but also scale out horizontally by adding additional chassis into that cluster. Compare the costs and administrative complexity of an Oracle RAC or a SQL Server always-on environment to MongoDB's sharded environment. MongoDB shards offer a massive amount of horizontal scalability that is a lot more cost-effective and more easily administered than RAC or always-on. The challenge is they don't have a lot of support from third-party application and tool vendors. How many enterprise COTS applications work with MongoDB, MariaDB, or Amazon Aurora? You don't have easy access to DBAs and developer skill sets. They're kind of hard to find. If you're just beginning to build your support architecture, you have a much greater freedom of choice, but if you're entrenched with an existing vendor, you're going to increase your support costs when you add a new product into your architecture. In addition, you don't have the vendor stability as you do with the larger competitors. Of course, you will with Amazon, but the smaller competitors you won't. You'll have a greater chance of a smaller vendor merging, getting purchased, or going out of business entirely. Who wins? We do. Competition is good for the DB consumer. An increasingly competitive marketplace forces all vendors to maximize their product's inherent feature set. Constant innovation and integration of new features that differentiate their product from other vendors is an absolute requirement for their continued competitive survival. In the past, we were required to use high-priced relational storage engines for all database-driven applications. There were no other alternatives. If the data didn't fit neatly into a relational model's rows and columns, we jammed it in there anyway, using a variety of kludges and workarounds. NoSQL architectures allowing us to more easily store non- and semi-structured data, cloud databases from industry leaders, and open source alternatives are now providing DBAs with the ability to custom tailor an architecture to their shop's budgets, as well as the application's unique storage and processing requirements. Open source alternatives allow us to choose cost-effective alternatives to commercial products. And we feel safe knowing that those products are supported by a vendor and they're not supported by the public. The last thing that we want to do is post a question to a forum when we have a mission-critical database down. The challenge is, how many different database products do you want to support? How many vendors do you want to deal with? Is it cost effective to have to train a staff in 6 different database products that are all supported differently? Let's turn our attention to relational versus NoSQL. We're aware that the era of the one-size-fits-all database, it's been over for some time. We realize that not all the data our shops are required to store, process, and present to end user neatly fits into relational row and column. The need to store unstructured data in conjunction with the ability to provide high degrees of scalability, data distribution, and availability were the business drivers behind the birth of NoSQL offerings. Many of the NoSQL products were specifically designed to leverage low-cost hardware to provide extremely high horizontal scalability and data redundancy at an affordable price point. Document, graph, key value, wide column, and other non-structured data architectures, they became viable competitive offerings because they offer a solution to the business community's need to store semi and non-structured data. Let's dig into this a little bit deeper on the next slide. So why is unstructured data growing faster than structured? It's because application needs are changing. Here's an example of what the NoSQL vendors describe as a modern application. It's that bottom graphic. We have an image being displayed in the upper left, an audio clip, free-form text, geospatial data, videos. These unstructured data types historically have not been easily stored in relational rows, columns, and tables. I provided some industry forecasts by IDC and Gartner. They show that as IT professionals, we are going to have to contend with an exponentially increasing amount of unstructured data. I give you some examples on the left side of the screen. Sensor data, biometrics, radiology, CAT scans, x-rays, about doctor's notes, videos, images, weather data, catalog, geospatial, social data. Here's a few quick examples of NoSQL architectures. Each vendor is providing a unique storage and processing architecture. MongoDB, it's a document database. The first time I saw a document being inserted to MongoDB, I was trying to figure out where the document's definition was. I was trying to compare it to an Oracle table definition, which has to be built before you insert data into it. I was told that there wasn't a definition, that the document schema is automatically created when the document is inserted. You insert the data, and MongoDB creates a schema during insertion. You don't have to predefine it. A document can be loosely compared to a row in a table. A group of related documents is a collection, and you can compare a collection to a relational table. The difference is, as a relational DBA, I have to pre-create that table before the developers can store data. But in MongoDB, we don't need to predefine the structure before storing data in it. It pretty much takes what you insert and stores it accordingly. And each document can have a different specification. Each document or row in our collection can store a completely different set of data. Graph databases allow you to traverse the data using named, predefined relationships. Neo4j is an example of a graph model. You can run a query that says, give me all the DBAs who work for RDX, who know both Oracle and SQL Server, who are BI experts, who work the third shift, and have written articles for the RDX blog. Very complex requests can be quickly returned. It combines the relationships together and returns the results. Cassandra wide column data store. Its claim to fame is extremely high degrees of horizontal scalability. The ability to spread your data throughout your geographic enterprise and super fast read and write performance. Cassandra and the company that provides support for it, DataStax, uses denormalization to improve performance. Their recommendation is that you build one table per query. That's absolute blasphemy in the relational model. You're duplicating data. Cassandra overcomes that with high-performance reads and writes. When we take a look at these NoSQL architectures as a group, it's really hard to collectively analyze them as a group because their storage architectures are so dramatically different. In general, they allow you to store structured, semi-structured, and non-structured data. They ingest pretty much whatever you want to put in them. They also provide cost-effective scale-out mechanisms. They're easier to administer and cheaper than the larger vendors' offerings. Cassandra and MongoDB, they'll allow you to easily distribute data throughout your data centers, whether that data center is across the city or across the country. This ability to scale comes at a cost. We'll learn in next month's presentation that transaction consistency is a challenge for most NoSQL products. The data that you think might be permanent might not be. It's instant consistency versus eventual consistency. That can be a problem. You just need to be aware of it. Because these products are niche offerings, they don't have wide support from third-party application and tool vendors. Relational databases, they have a very large customer base and a very large number of installations. That means you have a lot more third-party apps and tools that work with them. They also have very robust 24/7 product support. Because of their size, you don't have to worry about them going out of business. The products are feature-rich, and they have a wider scope of application than the NoSQL counterparts. You can use them to solve many types of business problems. That doesn't mean they solve all of them. It means that they can solve more of them than most of the NoSQL offerings. They can be expensive, complex to support, and rather inflexible when compared to the NoSQL offerings. In addition, they certainly don't lend themselves to easily storing non- or semi-structured data. And we'll be showing you how some of these databases ingest and store non-structured data in next month's presentation. Who wins? When we compare relational to NoSQL. It's important to note that in this part of the presentation, we are comparing vendors, not technologies. We are all aware that the vendor with the best technology doesn't always win the battle for market share or even survive as a viable competitor for that matter. This especially rings true when those vendors are up against offerings provided by much larger and more entrenched competitors, especially when you're facing competitors like Oracle, IBM, and Microsoft. Although NoSQL architectures will continue to grow in market acceptance, the vendors that initially offered them may not. The larger relational vendors will attempt to co-opt any NoSQL technology that challenges their dominant role in the industry. As they identify these offerings as tangible threats, their strategy will be to ensure that technologies used by those vendors become a component of, not a replacement for, their traditional database product. NoSQL vendors that use technologies that are easily integrated into a competitor's product, they're going to be the first to be consumed, or they're going to have to merge with others to survive. These smaller vendors will be required to constantly innovate and integrate new features that differentiate their products from their larger competitors. And once again, we go into that in next month's presentation. They are adding relational-like features. Why? They want to expand their customer base. So they coined a new term. It's called multi-model. Multi-model means that a single database product can store different types of data seamlessly, both relational and NoSQL unstructured and structured data. So when we use the term multi-model, at least from the relational vendor's point of view, what that means is I'm just going to take your technology, put it in my product, and then put you out of business. Oracle and Microsoft, they support NoSQL JSON documents. Who are they targeting? MongoDB and CouchDB. Oracle and Microsoft both have significant efforts to improve their in-memory database management systems. They're targeting Redis. Those vendors that have niche offerings with limited market appeal or have complex processing architectures, DataStax Cassandra is an example of a fairly complex architecture. They're going to be less attractive to their larger competitors and have the greatest chance of surviving future market consolidations. Their architectures are so complex, the bigger vendors won't incorporate their technologies. It won't be cost effective for them. They won't gain enough market share to justify the cost of integrating a complex technology into their product. In addition, there will be NoSQL vendors that survive. They will remain as viable alternatives, not because of the superiority of their architecture and feature sets. The reason will be their offering consists of a unique storage model that is also open source, a combination which allows them to be viewed as attractive, cost-effective alternatives to commercial products. Let's finish up this database wars comparison with open source versus commercial. One of the market areas that I think are going to continue to become just increasingly competitive. Open source database management systems provide consumers with the benefits of little to no upfront licensing costs. The database software is distributed under an open source licensing model that often varies in restrictions according to product and vendor. When compared to their commercial product competitors, open source offerings were historically characterized as niche offerings with limited features, functionality, and vendor support. As a result, organizations often shied away from open source offerings that were not commercially supported. There was no stable, mature provider that they could rely upon for product support, patches, and upgrades. They just felt uncomfortable implementing critical or mission-critical apps that were publicly supported. It's important to note that open source doesn't mean the product is totally free from upfront licensing and/or ongoing maintenance costs. Many open source DBMS vendors provide base functionality in their free open source offerings and a higher level of features in versions that have upfront purchase costs or require subscription-based support contracts. The key differentiator is that upfront licensing and ongoing maintenance costs are significantly lower than their commercial competitors. A new class of service providers has stepped in over the last few years to provide 24/7 support for a growing number of open source database products that include PostgreSQL, MySQL, and its derivatives MariaDB and Pacoda, MongoDB, Cassandra, and the list is growing. This growth in open source features, administrative tools, and available DBA skills combined with the traditionally high cost of commercial database product source code, the commercial vendors' complex and restrictive licensing agreements, and overly aggressive, some describe them as predatory, auditing practices, these are all combining to make open source products increasingly attractive alternatives to their commercial counterparts. Some of the challenges are the quality of vendor support varies according to vendor. They don't have their robust feature set than their larger rivals, but they are certainly adding new features very quickly. They're also smaller vendors that once again don't offer the vendor stability that the larger counterparts do. Commercial products have a much larger customer base. The vendors have robust 24/7 support and maintenance offerings, and the cloud is a significant part of their strategic initiatives. You have ready access to skilled DBAs, and there's lots of third-party application and tools available for them. Well, the downside is cost and complexity. DB Engines is a website that ranks the popularity of open source and commercial database management systems. The criteria they use to rank the database includes measuring the number of references for the product on industry websites, Google searches, job postings, as well as the number of mentions on professional and social networks. I looked in December of 2016 at the top commercial databases in web popularity. We're not talking about licensing revenue, we're talking about web popularity. In web popularity, Oracle, number 1, Microsoft came in at number 3, DB2 was 6, and Microsoft Access was number 7. The top open source products included MySQL, came in at number 2, PostgreSQL, 4, MongoDB, 5, Cassandra, 7, Redis, 9, and SQLite came in at the top 10 at number 10. If you look at the trend lines, you can see that the web popularity of these open source databases, it's going to eclipse their commercial counterparts sometime in late 2017. As I stated in the NoSQL section of this presentation, NoSQL vendors who survive will do so because they offer a unique storage architecture and they're also open source. Their key to survival is that combination. The larger commercial vendors, they're going to be hard-pressed to compete with these low-cost offerings. They can't co-opt a technology that makes their product cheaper. Well, they can, but they don't want to. So the only way that's going to happen is if they are forced to. Here's RDX's recommendation. Add an open source product offering into your supported products. Not every application requires the robust feature set of a commercial product. Why buy a tractor trailer to haul something when a pickup truck works just great? Does every database-driven application need the high licensing costs and all the features of a commercial product? Gartner is stating they are getting an increasing number of requests on those discussions specifically. I'm a big fan of both Postgres and MySQL. That includes Percona EDB and the MariaDB product vendors. Currently, I'm spending a lot of time digging into Enterprise DB, or EDB for short. EDB markets its Postgres Plus Advanced Server, long product name, but that product is a cost-effective alternative to Oracle. The vendor states that its product provides a deep level of compatibility with Oracle's features that includes a 100% drop-in for the PL SQL procedural language. Oracle SQL includes extensions, functions, packages, and replication. The product also provides Oracle-like tools, which includes EDB Plus, EDB Loader, and EDB Wrap. Sounds pretty close to Oracle to me, SQL Plus, SQL Loader. Shops that have a big footprint with Oracle may now have an option for an open source database alternative that won't require an extensive amount of training or retooling. Well, I certainly transferred a lot of information over the last, 45 to 50 minutes, and this wraps up the Database Wars presentation. I highly recommend next month's presentation. It may not be as glamorous as the Database Wars, but it's going to be a deeper dive into the NoSQL architectures. It's going to be easily understandable, so you can invite your boss and business folks that are interested, but it will provide you with a strong high-level overview as well as the most popular applications and implementations for these NoSQL products. What do you use them for? What should I use them for? That next month's presentation is going to answer that question. So we'll begin with an overview of the growth of non-structured data, the benefits that NoSQL products provide, and we'll continue with an evaluation of the more popular NoSQL products. In addition, when I started the presentation, you can also send me an email to join our newsletter. And a lot of these topics are also, I write articles, and they're provided in that newsletter. Kelly, do we have any questions for today?
Yes, Chris, we did have a couple come in throughout the presentation. So I'll begin with this one. Why did RDX choose to provide support for MongoDB as its initial NoSQL service offering?
Well, I think the main reason was that when I did a comparison, and it was a traditional product comparison. I wrote down a list of evaluation criteria. I spoke with a lot of people here at RDX, and I went out and did a market evaluation. And what I found was that as a service provider, we wanted to support a database that had the widest scope of potential application, meaning that more of our customers would be interested in using MongoDB because it can support many more applications than its competitors. And that was easily proven by its popularity. It has 10 million downloads, 1,000 partners, and 1/3 of the Fortune 100 use it. It's really easy to store semi and non-structured data into that product. It facilitates DevOps, rapid application development with those dynamic schemas. I was really taken aback by how quickly the development process occurs when you're not constrained by altering database objects all the time. And the product gets very good reviews for vendor support. So that was the top reasons why we chose MongoDB. Scope of application, vendor support, used by a lot of customers. The product has great reviews. Got any more, Kelly?
Yes, we do have a couple more. One attendee asked, I didn't see any coverage regarding Hadoop. Is it covered by NoSQL?
I'll be talking about Hadoop in the NoSQL presentation. And what I tried to do was come up with the most popular implementations of NoSQL and relational databases and use them as examples. When we do our deeper dive, Hadoop will be a part of that conversation. Next.
Another one that reads, how big of an impact will the Oracle licensing changes make?
Pretty big. I don't think what Oracle understands is that the reason that they beat DB2, I was around when Oracle eclipsed DB2 in product sales, and the reason why they did that is because their offering ran on many different architectures. Well, now Oracle is headed in the exact opposite direction. They're following, as far as I'm concerned, they're going to have the same issues that if they continue this, that IBM did, that you're limiting the number of platforms you're locking them in. So now, if you want to use Amazon, you're going to be paying double the Oracle licensing cost, which is already extremely high. So either you're going to choose Oracle's environment, or you're going to pay double on Amazon. That's, my personal opinion, that's not the right strategy to take. That's not the strategy that they use to become the market leader in database management systems. That's not the strategy. You tell I'm getting somewhat irritated, but that's not the strategy they use to eclipse DB2. They're not going to do well with this strategy. Next question.
Okay, next one reads, where will these NoSQL database management systems leave DBA's positions and demands in the market? What would you advise RDBMS DBAs?
I mean, if we're talking about the growth in the database products, I think that you can tell that the products like MongoDB, Cassandra, they're going to continue to grow in popularity. I also think that Oracle, Microsoft, and the other larger vendors are going to incorporate NoSQL-like technologies into their products. And when you learn some of these NoSQL technologies, you'll be able to apply those basic principles to any number of databases that has that technology. It's like the basic disciplines of database technology in general, which is performance, availability, reliability, security. It's the same concepts that apply to all database management systems. You just use different terms, right? Different lingo, different tool sets. The same thing is going to happen with these NoSQL environments, that you'll learn how to use these JSON documents, the Neo4j environments, and as the other vendors that either try and incorporate their technologies into their product, or you'll have other vendors pop up as competitors that use that technology, you'll be able to transfer that knowledge. A good DBA that knows that environment can transfer the skills to many different products. Like I said, I think that Gartner is really hot on Neo4j, and we're going to describe the reasons why next month. They have a strong positive interest in MongoDB, Cassandra, and Neo4j. Any other questions?
Yes, we have another. How stable are the open source databases?
Well, it depends on which database that we're talking about. Right now, RDX supports MySQL, PostgreSQL, and a lot of its variants. MariaDB, and they're extremely stable. We don't have experience with EDB right now. That's why I'm digging into it. But we've have teams that are dedicated to MySQL, to PostgreSQL. I'm just using those as an example. And when I talk with those folks on a regular basis, especially when I create presentations like this, and our customers are using them to create mission-critical applications. And when I talk to our DBAs that support them, they're not afraid of those mission-critical apps. They don't scare them. So we have really strong DBAs at RDX. And if those DBAs are telling me mission-critical apps, they're not a problem on my product. We support them. We support them all the time. We don't have any concerns. That makes me feel comfortable, and it makes me feel comfortable recommending it to customers that they are ready for prime time, enterprise-wide, enterprise-class environments. Other questions?
That's all we had, Chris.
Oh, good. I appreciate everybody's time. I'm glad we were able to answer all the questions by my deadline here, which is, I think, 2 minutes away, so we did good. I appreciate everybody showing up for today's presentation, and certainly if you'd like to discuss the contents of today's presentation, or you'd like to sign up for the newsletter, send me an email. cfoot, there's no E on foot, cfoot@rdx.com, and I'd like to thank everybody for attending today's presentation, and thank you, Kelly, for all your help. Thanks, everybody. Bye-bye.
Thank you, everyone.